Hello, everybody. I'm Andrei, and I work for JetBrains as a Senior Vice President of Investments, Research, and Education. Welcome to Regionals. Great things happen when great minds come together. JetBrains wants to seek out great minds all across the globe, support their initiatives, and work together to create great things that will make the world a better place. That's why JetBrains is proud to be a Global Tools sponsor of the ICPC. There are already many great minds working at JetBrains, and together we have created some amazing things, like the Kotlin programming language, for example. It keeps on growing and growing in popularity. In 2017, Google began officially supporting Kotlin as a language for writing Android applications. We have also created professional development tools like Cline for C++ programmers, IntelliJ IDEA for Java, PyCharm for Python, and also educational tools that help people learn and teach programming. The regionals are the biggest contest in the ICPC calendar. Thousands of talented people all over the world team up to solve complex real-world challenges. These contests are the proving ground for future champions. But even if you don't make it through to the finals, the experience of competing in the regionals and the new friends you'll make along the way are priceless. Enjoy the ride. Best of luck to everyone.
Problem 4 was it was easy medium around as we estimated, but I feel like this problem was even little easy than the P3, but as we expected that there won't be many submissions on this, and yeah, there were less submissions than P3 on this problem. The teams who solved it 255, I authored the problem and Ajinkya prepared it, and I would be presenting the solution. Ashwin, can you go to next slide? Yeah, so this problem, like we are given a graph and which is not necessarily connected. And what we want to do is like we want to find a connected subgraph which contains all the nodes and it's also bipartite. And additional condition was like the weight of the whole graph should be minimum. Now, like looking at this part that it should be connected bipartite subgraph, again, always tree comes to my mind. Like tree is a simplest bipartite graph. So that was the only observation this problem needed to solve. So yeah, so once we noticed that a tree can be a valid answer, then the part was to minimize the weight. So that can be minimized by picking up the MST of the graph. Like we always use the existing edges, then we add some more edges. The cost was absolute value of AU minus AV. But yeah, what can we do is like we can yeah, this next slide. Yeah, so we can sort all the nodes by AI values and then picking up on only the consecutive nodes and put one edge between them, because like we know that we can form a tree within n-1 edges. So like we already have some edges, and again by sorting them and picking only consecutive ones, we get n-1 edges. And Hodge cost is like AU comma AV. Considering AU comma AV, the absolute value is minimum if they are consecutive. Because if we take any other pair, let's say some Z, then V to Z and Z to V, that would be even more cost. So this was again one more insight to start with the greedy solution. Now, like we can consider only these edges and sort them with the cost, and then we can start picking the ones with the smaller cost. And the solution can be implemented either by forming the MST, or we can also do union merging. So both of the solutions take n plus m log n time. And yeah, and like we thought like there might be more possible solutions to this problem. So we had put limit like the outputted graph can have up to 2n edges. Like we thought that there might be more subgraphs which are bipartite, and if someone thinks, then that should be okay to accept.